Hey y'all, Data Guy here, and today I got an extra tasty video for you, breaking down all the different ways that you can pass data between tasks in Airflow. So as we all know, Airflow is kind of a weird situation where it's not meant for data processing in its own systems, but it manages data processing in external systems. However, there's a lot of Airflow workflows that do require at least some amount of on-disk data ingestion, and you even need to pass small amounts of data like variables between tasks or between DAGs, and using an external database for something like that would just be foolish. So instead, you use the local Airflow database, and there's a lot of different ways now where before, it was a very small database, very lightweight, couldn't really handle a lot of I/O. Now there's a lot of options for, not only managing data in different ways that's more efficient, but also adding external services into Airflow, attaching them like, external storage, custom XCOM backends to actually handle larger data sets. So you can do some amount of data processing within Airflow. And that's something I've been seeing out in the wild a lot. So if you're excited about this content, if you like my videos, please like and subscribe. That's the only YouTuber spiel I'll do today. And without further ado, let's get into it. Let's show you some of these examples. So today I'll kind of be focusing within the Airflow UI because this is where you can actually monitor some of these XCOMs, and now you have the ability to look at code really easily in the context of the graph view. So this is where I'll kind of live, but just imagine all the code. You can also write in VS Code, and I'll drop a GitHub link down below in the description. So first one to look at is Airflow variables. And so Airflow variables are essentially just constants that live outside of an individual DAG that are common across your entire Airflow environment. So you can see here, you can set these programmatically at the DAG level. You just import the variable, and then you write a variable.get if you want to pull the value of a variable. And if you want to set the value of a variable, you use variable.set. If that variable has already been set, then you just use the variable.update to update an existing value if you want to overwrite that previous value. Pretty simple. And then you can also monitor these variables if you want to go look at them within the Airflow UI. So just easy graphical representation. So you don't have to go back digging through your code, and then you can encrypt these, edit them manually. So if you just want to make a quick edit and edit this variable across all of your DAGs, quick, easy way to do it via the graphical user interface of Airflow. And you can also import variables if you want to just bulk import them like from a CSV or something. This update. And so second way is through kind of a mismatch of, hey, I want to use the newer TaskFlow API and the cross-DAG API. Actually, let's cut that. I'll show you the newest way you can, if you're just using your TaskFlow API to define your task, how you can pass data between different tasks that are defined via the TaskFlow API. So passing data between the TaskFlow API designated tasks is pretty simple. So if I go into the standard XCOM task flow, you'll see you just have a sender and receiver task. And the way I'm passing data between these tasks is by, within the context of this task, setting context ti.xcom push, whatever your key is, and your value. And then you can see in the second receiver task, what I'm doing is just XCOM pulling that key value pair. So just take the key, take the value, pull that in from XCOMs. Now, this doesn't just need to be like a 3 value. This can be maybe a data set. It could be a pin or something like that, or a reference to an external data set, or it can just be a variable like, hey, I want to create this dynamically and then pass it to the next task. And the way that you can pass the return value of one task to the other and explicitly use the XCOM is by just having receiver task, sender tasks. You don't have to kind of mess around with actually saying, hey, this receiver task is going to read in this specific variable. So you could just make it a little more flexible to any changes, if you change any of those variable names. Pretty simple use case, but you can kind of extrapolate this out and do a lot of things between different task flow tasks. However, you're not restricted at all to just using TaskFlow tasks together. You also can go the standard XCOM traditional way, and this is just basically how it used to be done before the TaskFlow API, where you're just basically doing the same thing. You're taking that XCOM push action on the context of the task instance. So this context is just defining, hey, the local context of whatever's happening within this task instance. And then again, you'll see very similar implementation to the TaskFlow API if you're using this method. Now, where the TaskFlow API cuts down on some of the difficulty is that with just traditional operators, you'll also need to have this op kwargs and set a Jinja template to actually pull those specific values from that previous task. So you can't do the nice little, hey, just function and one task inside of the other. You actually have to reference, hey, pull this specific task key or task output from this specific task ID and this specific key. So just a little extra code you have to write, and a little more brittle if you change any of those variables. Now, if you want to mix both of these together, you can. So it just is going to kind of have a mishmash of both. So here we have a DAG. I'll go to the graph view so you can see what's happening here, where we have just two different setups where we have one sender task that's from TaskFlow into a traditional, and then the opposite from traditional into TaskFlow. So let's look at what these two approaches look like. So first one is sender task traditional. So you see here we have a bash operator that is just echoing hi, right? And so what I can then do here to then process that information downstream is I'm going to create this receiver task TF that is going to take one variable XCOM received. And then what I can do is just add this sender task.traditional.output to reference the output attribute of this task. So if a task is producing a data set, you can reference that by adding the .output attribute to that object, and it'll return whatever that return value is from the XCOM. And you can actually look at this in the individual tasks. So if you go into your rendered template here, you can see the echoed greeting that you're reading in, and then what you're creating from that as well. And you can also see the environment variables too. So this is the return value that you're going to be sending into that next task. So if you want to audit that your data is being sent properly, this is a just easy way to go and quick check it. It's how I've debugged my code many, many times. So that's from traditional into TaskFlow. Now, let's say I want to go from traditional traditional into TaskFlow, sorry, getting ahead of myself. And now let's say I want to go TaskFlow into traditional. So here, if I want to go from a TaskFlow output where I'm just returning this value hello and send that into a downstream traditional operator like the bash operator, but this could be really any operator. It's going to be a similar function where you're going to add this environment tag, and then similarly to how that old style way of sending those operator or XCOMs I showed you in the traditional linkage, you'll have a similar thing here where you're going to output it just using the simple TaskFlow API, just return it, and then automatically it's put at the output value. But then you have to pull it in the traditional way by referencing that specific task in the ti.xcom pull, so pulling that return value from that specific XCOM instance. And so then you also have to set the bit mapping as well. So a little bit more annoying. And then these two that I skipped over here are just slightly different ways. So if you really want to set a template for how this is going to be passed to that downstream task, you can define that actually within the task definition, and that will take the information passed from that previous traditional task. So this is again just pulling from this sensor task traditional and pulling task ID key, seen this before, and then you read it in there as context because you're pulling in that XCOM received kind of as a context variable. So this pulls it in dynamically. Just a slightly different way of doing it. I honestly just prefer to do the dot output because I think it just makes more sense. But if for some reason that gets screwed up, if you want to explicitly pull, maybe just one certain value, if that previous task is returning several different return values, this is a good way to approach that use case. So that's kind of the mix max of TaskFlow and traditional within the same DAG. But what if you want to send XCOMs or information between different DAGs, not just different tasks? So if you're pulling between DAGs, that is a little bit difficult, but it's honestly kind of the same approach. So what you'll do is go, you have your sender DAG. So in this case, I have just a one task sender DAG where I am taking a TaskFlow API created DAG, and I am explicitly pushing the XCOM push value of this specific task instance with my key and value pair here as well. And then this return value also. So here I'm actually sending two return values. And this is because I just wanted to show you two different ways you can push values from an XCOM or TaskFlow. So if you wanted to add this to your traditional task, you could as well. But if you just are using TaskFlow API, then you can just return here with the return value. And you can also see here we're taking this today's date and passing it via Jinja templating into this value. So we know to reference this specific value. And that'll come into play when we go into our receiver DAG. So let's head over there and check it out. So to actually receive this task information from a prior DAG, it's a good amount of code, but not super complicated. I mean, it's just annoying that you have to have 5 lines to actually pull in a XCOM from a previous DAG, but I'm probably just a little too nitpicky. And so what we're doing here is to actually pull that value from another DAG. You're still going to be using that context ti.xcom pull method, but here you're also going to pass in the DAG ID, task ID, your key, so it knows to take that specific key value. Otherwise, it'll default to your return value. And then you can say include prior dates, because typically your sender and receiver DAG aren't going to have the exact same execution date time. So this is one of those little quirky things around Airflow. Obviously, your receiver DAG isn't going to start at the exact same time as your sender DAG, unless you're just running a silly sensor at the beginning of your receiver DAG. So make sure you include prior dates, because this includes even if it was a second before. So it's going to error out if you don't. I actually tried to make it work, and it just doesn't without including prior dates. So here again, context ti xcom pull, include prior dates, and you have again just the default key is the return value. So in this one, just pulling that default return value. So a little bit annoying to just pull a variable in, but not super complicated. And this is something typically you're doing for larger data sets. Why not just use the variables method? Because it's much easier to just pass individual little values. And so that's how you pass data between DAGs. We've shown you how to pass data between tasks. We've shown you how to set global variables that can be used by any task. So now I'll explore a few other kind of just, more edge cases, not really edge cases because they're very popular, but just different ways you can also use TaskFlow API to interact and pass data between tasks, and just, access different data points across your environment, because that's what this is all about. It's data pipelines. So the first one I wanted to show is, I need to pull from several senders. I have multiple different inputs coming from different tasks all into the same receiver task, or I want to pull from a specific task instance. Maybe I process the data for 4 tasks, but after I process that data, I want each of those 4 tasks or 4 task instances to map to a different downstream task. So the way I will do or mimic this is by first, I have my map sender task. So this is a simple, task as I just showed you before, where we are returning good dog deserves a treat. However, what we're doing is also expanding this. So using dynamic task mapping, check out my other video on that if you want to learn how to do it, to create one task instance for each of my good dogs. Then what I'm doing downstream to actually or other sender task, I'm just returning a set of values. So this is, just a simple dictionary. But I'm going to show you how to also pull a specific value out of that. So what these have the effect of doing is basically if I want to just reference a specific, map task instance of this map sender task, then I will add these map indexes argument. And so what this will do is say any task instances, mapped indexes argument here, any mapped indexes between -1 and 1, so in this case just the ones at 0 and 1, I want to take their values in. And I also want to read in all the values from my sender task. So what this looks like if we go into the graph view and look at the rendered template is this receiver task is ingesting only the first 2 results of the first 2 map task instances of that map task. And then it's pulling in that full list from the other task because it didn't ask or specify a specific index. And so really, just kind of expanding the complexity of you can pull in specific dynamic values and showing more of the complex ways you can interact and have data pass between different tasks when you start mapping and using dynamic task creation to just make your DAGs a little more dynamic since that's all the rage these days. So that's how you kind of do multiple senders. I want to ingest multiple task inputs. Then if we go into a very cool Astro SDK example of how you can pass data between tasks. So the Astro SDK, open source SDK project that just simplifies some of the typical operations within Airflow. So I won't get too deep into it now. I've made some other videos on it. But I wanted to show you how this simplifies some of the passing data between tasks. So here, I'm importing the Astro SDK SQL, which just allows me to execute SQL statements really easily and return them as SQLs, and the table object. And so that is so I can just create data set objects of SQL tables. So here, my AQL data frame, this is creating a pandas data frame and just returning it as an XCOM. So traditionally, you can't actually return pandas data frames via XCOMs. With the Astro SDK, you can, and then you can also read them back in downstream tables. So let me actually show you the graph of this real quick so you can see what's happening. So we have creating a data frame, so creating that pandas data frame, then we're going to read that pandas data frame into a downstream task, select certain columns, and then pass that downstream again. So with the Astro SDK, you can say, hey, just return that as output, just like you would with any TaskFlow task. The main benefit here is just being able to use it for pandas data frames instead of just more simple data forms. So here you see I'm defining createDF. I'm just giving it some random columns and defining the output table as a table within my local database. So this is just, can be any database. It could also be your local Postgres database, or this is where, if you want to attach a larger database, if you're passing a lot of pandas data frames, you can do that and then define the database connection here. And then you set the database in the back end of Airflow. Then what we're doing in here is taking, at AQL transform, where we're reading in that pandas data frame. So here you can see full table. So the results of this full table, this creating data frame, is read into this AQL transform statement, and then we're able to execute the SQL command on it. Read that data frame in. Astro SDK takes it into a SQL queryable data frame or data source under the hood, runs that SQL query, and then returns it and is read in again in this downstream task back as a pandas data frame. So this makes it a lot easier to pass data between tasks, especially if you're working with pandas data frames. But I won't show it too much. I just think it's really cool. It's open source, it's free, so it's not me trying to sell any product on you. And then we also have, so my final example that I'm going to show you here is just something that I think is kind of cool. That just shows the flexibility of XCOM and TaskFlow. Now that they've undergone a lot of upgrades. I admit they did kind of suck before. But here you can even use or you can even transfer data in and out of a Python virtual environment really easily. So maybe you're spinning up a Python virtual environment to run some Python specific code. Maybe whatever reason, maybe you need to install some separate libraries just for that task that can flick with your core Airflow dependencies. That's something I've seen a couple times. But the way you'll do this is pretty simple as to any other type of task. So all you'll need to do is just define a output here. So when you're in this function, I'm just returning a set of 1, 2, 3. Then what I'm doing is taking that as an input into this Python virtual environment. So notice Python virtual environment is TaskFlow compliant, so that helps a lot here, where I can read this input in, so the results of this task dynamically. You can see this nice little nested task declaration here, where I'm going to read this input in, and then I'm going to return the output just with an integer wrapper, so it knows that, hey, this is an integer that is being outputted, and that's just because we're exiting a Python virtual environment, so it needs to know what format to return it back out to Airflow is. And then you can just read that using the output of that previous task just by saying, hey, Python virtual environment, pass it into downstream task. And so that's the last thing I wanted to show you today. I feel like this has been a pretty exhaustive list of ways to pass data between tasks. But if you have another idea, if you have some ways you think of you could take this further, please let me know. Oh, actually, one more thing. So I wanted to show you where you can go if you want to look at all your XCOM informations in bulk. So you can see here, I have all my different return values. So if you want to scan through and figure out, hey, I just want to search for, a particular tag ID or particular task ID, you have that option. You can use, these search features here. You can monitor all your variables here and take this all in via the UI if you don't like just monitoring through code and task outputs using the render template. And now that's actually all I have for you today. So please, again, like and subscribe if you like this stuff. And let me know if there's any topic you'd like to see covered. I am always just doing this to help you all. So have a good one. Data Guy out.